Alright, what I'm looking at here is, I'll call this one collisions delta P and force. So when we have a collision, we'll use A, if you like, comes racing along, hits B, which is maybe stationary. B flies off up here, and A flies off down there. It's normal collision. Collisions get quite complicated, and you'll have already seen my little video on collisions. But using conservation of momentum and principles like that, we can calculate things. And this little video here, I know you're all pretty good at this already, but if we've got a change in momentum, so A has a change in momentum. If A's delta P, and you can do that because you can get the velocity. If you've got the velocity of B and the velocity of A, we've got the velocity initial, velocity final, that's for B, velocity final for A, it's velocity final for B, velocity initial for A, velocity initial for B. We can do all those calculations, and remember, delta P is equal to P final minus P initial. Right? If you end up with a delta P for A and it looks like that, then you know immediately that your delta P for B looks like that. They are equal and opposite, and they are equal and opposite because of conservation of momentum. If you've got conservation of momentum, you're saying total momentum before and after the collision is constant. So if total momentum is constant, then any change in momentum on A, or delta momentum, or change in momentum on A, must be equal and opposite to change in momentum on B, and therefore the total momentum will stay the same. Now that's all very well. We've got this impulse equation which says that force times delta T is equal to delta P. That all basically comes from the F equals ma. Now if delta P is divided by delta T, then we get the force. So if this here, that little vector there, is delta P for A, then if we divide that vector there by delta T, then we've got the force acting on A. If we do the same thing here, delta T, then we've got the force acting on B. So what we can say for sure again is that the force acting on A acts in the same direction as the change in momentum. So there is an equal and opposite force in this collision acting on each ball, Newton's third law. Just again, this is just a reminder, just to make that solid for you.